Assalamualaikum warahmatullahi wabarakatuh. My name is Nuradeba Binti Harfizi. My matrix number is AA191597. For our group project, our group, which is group 3, will explain the application and technology related to a hydraulic infrastructure that we chose, which is dam. Before starting, I will briefly introduce my group members. The first one is Nuradeba Hanim. Next is Iman Elianie, and lastly Farhanah. A hydraulic infrastructure or system is built to support the pressure and weight of a water body. Besides that, it is also built to regulate or control the flow of water to the respective purposes. A dam is a barricade or a barrier that restricts the flow of water or underground streams. Dams are very useful and important since they offer a range of economic, environmental, and social benefits, including recreational benefits. For example, dams create lakes for certain activities such as boating, fishing, and swimming. Not only that, dams are also important in managing crises by suppressing floods and redirecting its course towards other uses. The main function of dams is to provide adequate water storage to ensure regular water supply to activities such as irrigation and industrial activities. Other than that, dams can conduct electricity by using hydropower, which is a clean source of energy that will not cause pollution. However, despite having many advantages, there are also disadvantages of constructing dams. Environmentally, huge dams could disrupt local ecosystems and groundwater table. They could also cause the extinction or overproduction of certain aquatic species. At the top of it, huge dam increases the risk of a man-made catastrophe or disaster as a result of the destruction of the dams, and it could cause damage to properties, the economy, the environment, and the worst of all, it is also fatal. As a conclusion, the planning and designing process of the dam construction must be heavily considered.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuradeba Binti Misnan. I will continue with next presentation, which is I will explain about process a dam. First, protection of the embankment from upstream wave action, which is stone riprap commonly used. Second, prevention of erosion on dry downstream side, which is grass, stone, or concrete. Third, all vegetable matters and organic material is clear from the dam site. Fourth, ground holes for the cut of certain are drilled to adapt where the ground certain will effectively seal out the seepage of water beneath the proposed dam. Next, I will explain about how to build a dam. First, engineer must be dewater the river. It is done by diverting the river through tunnel. Tunnel may be lined with concrete and dug out using a combination of drilling and explosive. Second, started when the river level are low. Small dam were built upstream and keep construction zone dry. Pump may be used to remove water. Third, remove the loose rock and a plinth must be constructed. Plinths prevent water from leaking at the edge of the dam. The last one is concave curve downstream for a dam helps it absorb the constant pressure of water. Reinforced steel are used for surface and the main enclosure is built. Enclosure filled with concrete to make it extremely strong and resilient against water flow. Next is type of dam. We have 5 types of dam, which is the first one, arch dam, buttress dam, embankment dams, gravity dams, and spillways. The last one, I will explain about method of dam. We have 2 methods to build a dam, which is hydraulic fill method and a roll fill method. For hydraulic fill method, dam body is constructed by excavating and transporting soil by using water. Second, soil materials are mixed with water and pumped into these pumps. The last one, sludge is discharged through the outlet in the flammers at suitable intervals along their length. For rolls fill method, embankment is constructed by placing suitable soil materials, thin layers which is 15 until 13 centimeters, and compacting them with rollers. Second, ordinary road rollers can be used from low embankment. The moisture content of the soil fill must be properly controlled.
Assalamualaikum warahmatullahi wabarakatuh. My name is Iman Elianie Binti Mustapah. My metric number is AA190182. I will present to you about technology in dams. Our first technology is hydropower. Hydropower is the most well-known water technology. Hydropower is unlike typical gas, coal, and other fuel-burning facilities because it does not require the purchase of fuels for generating. Modular hydropower system for non-powered dams and other unexplored locations can reduce development costs while also reducing natural effects. Dams can be built on rivers, oceans, or lakes. The primary source of water energy are large hydroelectric dams on major rivers. Large dams also provide a variety of social functions, including water system, surge control, and diversion. Climate change renders hydropower ineffective. A delayed dry period may cause the stream's water level to drop, and it will lead the electricity generation to reduce. The second is powerhouse. The powerhouse and spillway are major elements of the concrete part that is often included in composite dams. This type of dam combines the advantages of both soil and concrete dams. The potential energy of water is converted to a motor that drives the turbine using a simple principle. In the case of run-off the river dams, the potential energy contained within the flowing water is changed over through a simple concept to a drive that turns the turbine. The turning of the turbine gives the desired mechanical energy to control a generator for electricity generation. The third is the turbines. The most common types of turbines used in dams are impulse turbines and reaction turbines. Impulse turbines is where the water can enter the casing with a large wake and flow through, where high-speed jets of water from a nozzle impact the symmetrically formed edges settled on the rotor. The water motor control is transferred to the rotating wheel, and the strain is transferred to the channel and outlet. The fly's resultant propulsion make a difference in turning the turbine, which is why it is termed an impulse turbine. Water is taken from upstream of the dam by reaction turbines and transported through the penstock underwing, where the vector sum of impulse and reactive force are struck asymmetrical from edges. These turbines are constructed with the dams and have entirely varied bearings based on the site topography, head of water, and discharge. This type of turbines are classified as Kaplan or franchise turbines.
There are different types of dam all around the world, such as gravity dam and embankment dam. 93% of dam types is by far composed of earth and rock fill dam. Different types of dams have different consistency of materials. For example, a rock fill dam is an embankment dam, with more than 50% of the volume consists of compacted or dumped pervious natural or crushed rock. Thus, foundation requirements are less stringent than for other types of dams. 51% of dam failures are caused by foundation failures, including uneven settlement and earthquakes. Next is inadequate spillways, with a percentage of 23. 7% of dam failures are caused by piping and seepage, including embankment slips and high pore pressure. Meanwhile, 19% of dam failures are caused by other issues, such as defective materials and improper construction. Besides that, dam failures can also result from overtopping. These failures could cause the dam to breach or destruct. It is clear that the most frequent issues related to the dam construction is foundation failures, inadequate spillways, piping and seepage, overtopping and other issues such as mentioned earlier. The planning, designing and execution of the dams must be done properly in order to avoid overall dam failures.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farhanah Binti Bakar, number matrix AA191797. I will present the recommendation and conclusion. For the recommendation, the engineer might utilize load stability computer algorithm to search for crucial failure surface within a field embankment. And other than that, there is one technology that can be used, which is unmanned aerial vehicles. It is one technology that can be employed during the construction period. It is also used to create a 3D model to track the development the project of dam using BIM and provide real-life data of fracture and dam movement. So, the incident can be avoided and cause less harm because engineers are aware of what is going on with the structure. So, the conclusion is dams are known for both their good consequences such as flood control, irrigation and hydropower, while the implications are displacing people, disrupting environmental service and livelihoods. It is also assists people in many ways, such as flood risk mitigation, electricity generation and agriculture. There are many elements that can consider to build a dam, such as existing facility, include the age, condition, and adequacy of existing structure. So that's all from me. Thank you.